In this video, we'll look at analyzing your physics IA. We'll discuss what to put in your data collection and data processing sections. Note that I've made separate videos for propagating error, how to calculate with multiple measurements and your data collection table, as well as how to linearize your graph. So this is a data table that I used in a previous video. It came from using Audacity program to use echoes to measure the speed of sound. The independent variable is the distance, and the dependent variable was the time it took for the sound to come back for the echo. One of the first things you need to think about is with your raw data, that's all of these values in here, not this column or this column, but with my raw data, have I collected enough? Is it sufficient? The rubric actually states the report includes sufficient relevant quantitative and qualitative raw data to support a detailed and valid conclusion. So let's talk about the sufficient first of all. We suggest that you change your distance, your independent variable, at least 5 times. Check, got that. And your dependent variable should be done at least 3 times. In this case, I've done more because there was a lot of variation and it was fairly quick to collect. Quantitative and qualitative raw data. So I've got definitely quantitative data. And in physics, we're a little bit more lenient with the qualitative. Remember, all sciences use the same rubric. Are there any things like color, smell, touch, observations that should go with this data? Many times things like, oh, the ball wasn't falling perfectly straight down to the ground, or there was some wobbles in the movement, things like that should be included in your raw data, as this will help you later in your analysis. Note sometimes that we collect data and we do our measurements and it has to be processed before we get to our dependent variable, and that should be pointed out. Now these times are really short, and that's okay because it came from the Audacity, a computer program. If you are measuring time with a stopwatch, please realize it's not valid to have values less than 1 second. Take a look at your table. Does it have units? Does it have uncertainties for the measurements? What I mean are these uncertainties here. In addition, after you calculate your average, make sure you do your uncertainty using the range by 2 rule. One final thing to point out is make sure your data has a consistent number of decimal places unless you've changed for some reason the measuring tool, and then again you need to be explicit in what you've done. What we want to see here is nice, easy to understand data. One thing we don't want to see, and why there's a limit of 12 pages, is in the previous syllabus we're getting pages and pages of just data. For example, let's say you were using a data logger like a LabQuest, and you had a cart running down a hill and you were really only interested in using it to get acceleration. Show one graph and how you got the gradient from the graph, and then put all the rest in the data table. That really is something you want to be considering. You show one sample for each calculation. One other thing is, don't think, oh, I'll just put everything into an appendice. The examiners do not need to look at an appendice, and in fact, they shouldn't be considered. If you can't put it in your 12 pages, then you are not being concise, and that's what we're looking for. We are looking for quality, not quantity. In this section, and perhaps also in your background as well, you're going to have tables and figures and graphs. Everything should have a title. Figure 1, apparatus to measure wavelength of colored light, for example. Here's another figure with a title. It makes it a lot easier to refer to, and the examiner, the reader, can follow your discussion and analysis much better. Another thing to remember is everything you use, if you didn't make it yourself, you have to cite it. Some people forget that clipping photos, equations, everything like that, those also need to be cited. Make sure you follow the citation format that's been shared with you in your core classes or at your school to make sure you've got a consistent way for someone to follow where you can attribute your work. You can see in one of my other videos of how to make a graph, but here's some general things I want to point out. First of all, make sure they have an appropriate scale. We want to be able to see the features. We don't want to have your points just in one bottom little corner, or have dots that we can't see very clearly as part of your graph. Sometimes they get to the very edge and they don't stand out very well. Don't make your graphs too small on the page where you're saying to yourself, oh, I'm stuck, I only have 12-page limit. They've got to be really small. If they're not clear to follow and not clear to see, I need to be able to read the axes or anything else you have on there. I've also put in another video how to make sure your axes include the proper formatting of your units. Please don't play connect the dots. What I mean is by just connecting all the points together. We know that these came from measurements. We know that all of our measurements are full of some uncertainty because we're not perfect. Sorry to remind you of that. So we should have points there and we should have lines of best fit. Finally, under your graphs, include a paragraph that actually says what you were trying to do in your graph, what does it show, and some general analysis of what it gives us. So with your lines of best fit, in physics we do expect you to linearize your graph if you're trying to get something from it. There's a few reasons for that. First of all, like I say in my class, you can't fake a straight line. There's a lot of times where we have a curve and some students want to just choose any possible one, any possible curve fit that's going to get there, and perhaps even finding the R-square value closest to 1 just to say, hey, it's the best fit. But you really do need to have some theory to back it up. We can't just randomly choose an equation and say, look, this is what it's trying to show us. Use your error bars to make lines of max, min, lines of best fit to be able to calculate the uncertainty of your gradient. And I do have a separate video on how to go and linearize a graph. So if you've been following my video so far, you should be able to have an internal assessment so far that has a research question, background, the variables, a method, and now you should also be able to complete the data collection and data processing section. One last part will be the evaluation and conclusions.